Good morning, students. Okay, well, in this session, okay, let us try to understand some more concepts related to chapter number 2. Okay, today's concept is dielectrics. Let us try to understand what is the meaning of dielectrics. Okay, fine. Dielectrics. Very simple concept. Probably 1 mark, maximum 2 marks. What do you mean by dielectrics? A dielectric is an insulator. Dielectric is an insulator. Like paper, mica, pure water is also pure water, oxygen, or ceramics are some good examples for your dielectrics. They are insulators. They transmit electric effect. Electric effect and transmit ಮಾಡ್ತಾರೆ. They transmit electric effect without conducting charge. Charge conduct ಮಾಡೋದಿಲ್ಲ. They plays very important role in electrostatics, storing energy. They plays very important role. What they do? Basically, they are all insulators like paper, mica, pure water, oxygen, ceramics. They conduct electric effect. They conduct electric effect without conducting charges. Charge and conduct ಮಾಡೋದಿಲ್ಲ, but they conduct electric effect. Dielectrics. Okay, one more question. Enough. There are two types of dielectrics. Example I have mentioned. We classify dielectrics into two types. First one is polar dielectrics. Second one is non-polar dielectrics. Non-polar dielectrics. Polar dielectrics क्या होता है? There are some polar molecules like water, HCl, hydrochloric acid, NH3. These are called polar molecules. I mean polar molecules, yes, exactly. The dielectrics dielectrics with these polar molecules are called polar dielectrics. Correct. Let us understand what exactly are these polar molecules. Now, non-polar dielectrics. Best example is carbon dioxide, H2, O2, N2, so on. We have number of examples. Okay. What is the difference between these polar dielectrics and non-polar dielectrics? As I said earlier, these are made up of polar molecules. What are polar molecules? Fine. If you look at the structure of water or HCl, see here, we have one carbon, I mean chlorine atom and hydrogen atom. This is chlorine minus this is hydrogen. Cl. Here we have 1 point, here we have 1 point. This is minus, this is plus. They possess what we call dipole moment. They possess what? Dipole moment. They possess dipole moment. See, one strange thing you can observe here. Similarly, I will write H2O, water. oxygen, correct? Hydrogen and hydrogen. H2O, right? This is H, this is H, this is O, this is negative, this is positive, this is negative, this is positive. Your dipole moment is from negative to positive, we know this, correct? Correct? What we observe? Here, in dipole molecules, centers of positive and negative charges do not coincide. Centers of negative charge and positive charge do not coincide. They are separated by certain distance. They are separated by certain distance. Due to unsymmetry of these atoms, we observe there is a separation between centers of positive charge and negative charge. Or simply, I may represent polar molecule in this fashion. A negative charge and positive charge. This is the direction of your P, dipole moment. What we observe? We observe there is a gap, a small distance between negative charge and positive charge. They do not coincide. Center of negative charge and positive charge do not coincide. Such molecules are called polar molecules, and dielectrics due to such molecules are called polar dielectrics. Polar dielectrics or dielectrics having polar molecules where centers of negative charge and positive charge do not coincide. Simple. Maybe for, once again, 1 mark or 2 marks. Maximum. Define polar dielectrics and hence mention 1 or 2 examples. Correct? Here, non-polar dielectrics are made up of course, non-polar molecules. For example, H2. What we observe in H2? There is no much gap between, okay, there is no much gap between, okay, these two H. Or simply, I will show you a non-polar molecule is one where centers of positive charge and negative charge coincide. If you want to draw CO2, what we observe? CO, one by O. So, O. Almost your, what we call, dipole moment is 0. H2, almost dipole moment is 0. Dipole moment is 0. Non-polar molecules are those in which centers of positive charge and negative charge coincide. Due to symmetry, they are separated by small distance due to unsymmetry of molecules. These are called non-polar molecules. Non-polar molecules. And hence, dielectrics so obtained by these non-polar molecules are called non-polar dielectrics. Very simple. Here, centers of positive charge and negative charge coincide. I can represent in this fashion. Dipole moment is 0 in the absence of external electric field. Naturally, they don't possess any what we call. They don't possess any dielectric moment. Okay, dipole moment. Whereas they naturally possess dipole moment. Correct? Here we have even difference between them. This is enough. This is enough. Okay. This is only for 2 marks. Please remember. We have one more important definition, so called Dielectric strength. This is also important. Right? Important. Dielectric strength. Dielectric strength. Okay. It's the maximum value of applied electric field. It is maximum value of applied electric field strength up to which the dielectric breakdown does not take place. Imagine you are applying electric field, external electric field, to a system containing your dielectric. Your dielectric strength represent it is maximum value of applied external field up to which dielectric breakdown does not take place. Dielectric ಏನಾಗೋದಿಲ್ಲ breakdown ಆಗೋದಿಲ್ಲ. ಒಂದು dielectric breakdown ಆಯ್ತು ಅಂದ್ರೆ ಏನಾಗ್ತದೆ? Current will correct. The strength of that dielectric up to which it stands at the electric field. Okay. So what we define? It is the maximum value of electric field strength applied up to which your dielectric breakdown does not take place. It's the maximum value of electric field applied up to which dielectric breakdown does not take place. Correct? Fine. This is 1 or 2 marks question. Okay? Fine. Now, here we have some derivations, all those things. Okay? I mean, not derivations, some theoretical explanation related to dielectric and polar dielectric and non-polar dielectric. Not going to deal that. Okay? Anyway, it's not important, I feel. What is important is second part of this chapter. That is capacitance. That is capacitance. Let's move towards that part, second part of this chapter, so-called electrical capacitance of a conductor. Concept is electrical capacitance of a conductor. Let me write, this is important. Let me write electrical capacitance of conductor. Remember, in this heading only, we are discussing electrical capacitance of electrical capacitance of a what? Of conductor. What is conductor? You know. Let us consider a conductor of any shape or some thin sheet or a thin plate. Remember, this is a metallic conductor. What we are doing? Capacitance we are doing. What is capacitance? We will discuss. Something related to capacitance. By some means, let me add some positive charges to this conductor, metallic plate, thin plate. What do you observe? There is some relation between electric potential and the added charge. Of course, there is some relation. Electric potential ಇಗೂ ಮತ್ತೆ ಈ ಕಂಡಕ್ಟರ್ ಮೇಲಿರುವ ಚಾರ್ಜ್ ಇಗೂ ಏನಾದರೂ ಒಂದು ಸಂಬಂಧ ಇರಬೇಕು. It's a very simple what we call common sense, very much common sense, that your electric potential must be proportional to added charge. If you increase charge, the electric potential also increases. Both have direct relation. Your electric potential is directly proportional to charge. Number of charges if you increase, electric potential also increases. Of course, due to that equation only we can tell what electric potential increases. Electric potential of this object, this body, this conductor increases. They have direct relation, correct? Fine. I can write this equation in this fashion also. No problem. Or let me replace this proportionality sign by a constant. Like Q is equal to some C into V. Q is equal to CV, where C is called capacitance of a conductor. Here we have this one. Capacitance of a conductor. Right? C is constant called capacitance. Remember what we get? I get C is equal to simply Q by V. C is equal to Q by V. C is equal to Q by V. How to define the capacitance of a conductor? Capacitance of a conductor is defined as it is the ratio of charges added to the conductor to potential increased, potential developed, or simply potential. Capacitance of a conductor is defined as it is the ratio of charge applied to the electric potential. Correct? Electric potential. This is the definition, standard definition. Capacitance of a conductor gives you idea about capacity of that conductor to withhold charge. We'll discuss it later. Now, C is equal to Imagine if you are supplying 1 coulomb of charge so as to increase 1 volt potential, then how to define this? Okay. Then it will be, this capacitance will be 1. We have coulomb per volt. This coulomb per volt is called farad. Farad is SI unit of your capacitance. Is a thing to be remember. Farad is SI unit of your capacitance. Farad is SI unit of your capacitance. We usually represent it as F. Capacitance, I am using capacitor, correct? It's a conductor, I am discussing conductor. We will next move on to the capacitor. Correct? See, Farad is unit of your capacitance. You may get question to answer. Define 1 farad. 1 farad define money. How to define? Very simple. 1 farad is defined as it's a ratio of 1 coulomb of charge to the potential difference or potential of 1 volt, or capacitance of a conductor said to be 1 farad. Capacitance of a conductor is said to be 1 farad if 1 coulomb of charge is applied. If 1 coulomb of charge is applied, so as to increase its potential by 1 volt. Capacitance of a conductor is said to be 1 farad if 1 coulomb of charge is applied, so as to increase its potential by 1 volt. Correct? With this basic idea, let's move to capacitor, concept of capacitor. What is capacitor actually? Capacitor only. A capacitor is a system. A capacitor is a system containing two plates. Next one, initially I took conductor. Similar plates. This is plate 1, this is plate 2. Separated by a small distance. There is some distance. With A as area of both the charges. But the condition is, if this is positive, this is negative. If plus Q charge carried by first plate, then automatically charge will be equal, so that your net charge is 0. There is a net potential difference. If V1 is potential due to this plate, V2 is potential due to this plate, the net potential will be, potential difference will be V is equal to V1 minus V2. So, capacitance of a capacitor. Capacitance of a capacitor. Next concept, capacitance of a capacitor. Capacitance of a capacitor. A capacitor, a system containing two conductors separated by small distance. Why capacitors are used? What is the use of capacitor in physics, in electrostatic? Very important. Number one, they used to store charge or energy. They used to store energy or charge. Second, they are used as a filters in rectifiers. What do you mean by filter? What do you mean by rectifier? Chapter number 14. For timing, please remember. They are used as filters in rectifiers. Chapter number 14, last chapter discussion ಮಾಡುವ. But remember, they are used as filters in rectifiers. They block DC and allow AC. They block DC and block ಮಾಡ್ತವೆ, and they allow AC. What do you mean by AC and DC? You know, over high school knowledge probably you know. AC means alternate current, DC means direct current. How we will discuss in next sessions, upcoming classes, upcoming chapters. We use this capacitor. You can extend same idea to the capacitor, like a capacitance. Same you get. It is a ratio of charge supplied to the capacitor to the increase in potential. That's why I used capacitor in terms of conductor. Correct? Fine. Okay. A capacitance of a capacitor is said to be 1 farad. I am now using capacitor term. Please remember. Capacity of a capacitor is said to be 1 farad. If 1 coulomb of charge is supplied to the capacitor so as to increase its potential difference, there are two plates. Potential difference by 1 volt, because potential difference is also having SI unit as volt only. Its SI unit also volt. Hope you understand. Correct? Here we may discuss some interesting point, like what if there are different types of capacitors, parallel plate capacitors, spherical capacitor, cylindrical capacitors. What if you want to build a spherical capacitor? A spherical capacitor carrying charge 1 microfarad. 1 microfarad. What is microfarad? Let me explain. Farad itself is very big unit. 1 farad itself is very big unit. We use smaller units of farad, like 1 millifarad, which is equal to 10 raised to minus 3 farad. 1 microfarad, which is equal to 10 raised to minus 6 farad, or 1 picofarad. 1 picofarad, which is equal to 10 raised to minus 12 F. Sometime nanofarad. Sometime nano also we use. Sometime we use nano. Okay. Nano means what? 1 and F. Nano means 10 raised to minus 9. These are smaller units of farad. Okay. Now imagine you want to calculate a spherical conductor, okay, or capacitance of a spherical conductor. You want to calculate capacitance of a spherical conductor. Then what? See here. See, just to note, may not be very important to as far as exam concerned. Just okay, side thing. Capacitance of spherical, I use term conductor better. Spherical conductor, capacitance of a spherical conductor. Okay, visible. Capacitance of a spherical conductor. Let us consider a spherical conductor. With positive charge outside. With radius r. Remember this, as far as conductor is concerned, capacitance of this conductor depends on its size, shape. ಯಾವ shape ಅಲ್ಲಿ ಇದೆ ಕಂಡಕ್ಟರ್ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಮ್ಯಾಟರ್ ಆಗ್ತದೆ. ಯಾವ ಸೈಜ್ ಅಲ್ಲಿ ಇದೆ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಮ್ಯಾಟರ್ ಆಗ್ತದೆ. Spherical ಇದ್ದಾಗ even radius is a very important point. Radius is also one of the factor on which capacitance of a capacitor depends. Conductor depends. Capacitance of a conductor depends. Okay, you can use capacitor also, no problem. There are two spherical surfaces, spherical bodies involved. Simple. Okay. We know C is given by C is equal to Q by V, correct? This is the expression we have studied. Where Q is charge carried by this spherical conductor. What is V? We know expression for V. Q is equal to 1 divided by 4 pi epsilon naught Q by R, where R is its radius. Q will get cancelled. What it is? C is equal to 4 pi epsilon naught R. This is the expression for capacitance of capacitor, capacitance of spherical conductor. Expression for capacitance of spherical conductor in free space. Please remember in free space, because we have epsilon naught. Epsilon naught represents free space. Epsilon naught represents what? Free space. Well, now let us derive very important derivation for 3 marks. Okay. For 3 marks, it's the most frequently asked question. ತುಂಬಾ ಸಲ ಕೇಳೋ ಕ್ವಶನ್. ಕ್ವಶನ್ ಏನು? Expression for capacitance of a parallel plate capacitor without the electric medium. I will write as very important. Okay. concept is expression for capacitance of parallel plate capacitor without dielectric medium. Without dielectric medium, I'll write medium there only. Without dielectric medium. Without dielectric medium, visible, I think. Okay. Now, expression for capacitance of a parallel plate capacitor without dielectric medium. Okay. Let us consider two parallel plate capacitors. Plate 1, Roman number 1 with area A. Plate 2 at certain distance, Roman number 2, the same area. These are two identical plates with the charges plus on one plate, minus on other plate. Here, there is no electric field because they cancel each other. Correct? Field is opposite direction, positive in this direction, negative in this direction. So no field. Okay. Here, at this surface, if there is no electric field. Negative towards this, positive towards this, there is no electric field. At the same time, between these two plates, direction of electric field is correct in this direction, whereas negative direction is also same direction. So automatically we have to add electric field between these two plates. Correct? This is for your knowledge sake. Please remember. What I have to write? I have to write. Let us consider two thin plates, 1 and 2, which are separated by very small distance, say D. Distance of separation is D. Okay. A is area of plates. Okay. D is distance between plates. Okay. Distance between plates. And sigma B surface charge density. Surface charge density. Okay. Where sigma is equal to we know Q by E. This is the expression of chapter number 1 we know. Q by E. Surface charge density. Sigma is equal to Q by E. Okay. Let Q be the charge on plates. V be the potential difference. Please remember. Potential difference. Potential difference between two plates. Potential difference between two plates. Potential difference between two plates. This is the initial explanation. This is the initial assumption we have to make. Correct? Okay. If so, next. I will rub this so that okay, this much okay for me now. We know what capacitance of a capacitor, right? Now, capacitance of a capacitor is given by C is equal to Q by V. We are very much familiar with this expression, correct? We know this expression very neatly. Fine. Also, electric field I'm talking about now. Electric field between two plates. E is equal to electric field between two plates. E is equal to sigma divided by 2 epsilon naught due to plate 1, which is similar to sigma divided by 2 epsilon 2 due to plate 2. This is the important part of this derivation. In chapter number 1, we derived a relation, expression. Derive expression for electric field. Let me repeat. Derive expression for electric field due to thin, positively charged, infinitely long plane sheet applying Gauss theorem. Gauss theorem ಅನ್ನು apply ಮಾಡಿ first chapter ಅಲ್ಲಿ infinitely ದೊಡ್ಡದಾಗಿರೋ thin metallic sheet ಎಂದು electric field ಕಂಡುಹಿಡಿಯಲಿಕ್ಕಿದೆ. ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಅದು ಮೂರು ಡೆರಿವೇಶನ್ ಇದ್ದಾವೆ. ಒಂದು electric field due to thin infinitely long wire. Second, electric field due to thin infinitely long sheet, metallic sheet. Third, a sphere. Sphere li ಮೂರು ಭಾಗ ಇದೆ ಮತ್ತೆ inside the sphere, third part, on the sphere, second part, outside the sphere. ಇದನ್ನು ನೀವು ಕಂಡುಹಿಡಿಯಬೇಕು electric field ಅನ್ನ using Gauss theorem. ಅದರಲ್ಲಿ ಎರಡನೇ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ electric field due to a thin sheet. ಇದು ಒಂದೊಂದು ಪ್ಲೇಟ್ ಒಂದೊಂದು thin sheet ಅನ್ಕೊಳ್ಳೋಣ ನಾವು. ಹಾಗೆ ಅನ್ಕೊಂಡಾಗ electric field ಎಷ್ಟಾಗಿದೆ ಇಲ್ಲಿ epsilon ಇದು sigma, where sigma is your surface charge density, sigma divided by 2 epsilon naught. Epsilon naught ಅಂದ್ರೆ ಏನು? You know what is epsilon naught? Permittivity of distance. ಇದು ಒಂದನೇ ಸರ್ಫೇಸ್ ಇದೆ. ಸೆಕೆಂಡ್ ಸರ್ಫೇಸ್ ಇದೆ. This is for second surface. Epsilon divided by 2, sigma divided by 2 epsilon naught. ಎರಡು ಸರ್ಫೇಸ್ ಇದಾವೆ. ಒಂದೊಂದು ಸರ್ಫೇಸ್ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರುವ ಮತ್ತೆ ಎರಡರದು ಡೈರೆಕ್ಷನ್ electric field direction ಒಂದೇ ಆಗಿದೆ. So we have to add. Whereas here electric field is absent, here also electric field is absent. Correct? This is the basic idea. What we get? We get E is equal to epsilon divided by, I minus sigma divided by epsilon naught. Okay, just I'm telling sigma epsilon everywhere. This is equation 2. This is equation 1. This is equation 2. Also, also from this chapter only, we know this relation. What relation? I will write here E is equal to minus delta V divided by delta L. Correct alva? ಇದರ ಒಂದು ರಿಲೇಶನ್ ಮಾಡಿದ್ವಿ. ಏನು ರಿಲೇಶನ್ ಇದು? There is a relation between electric field and electric potential. Electric field and electric potential. Minus indicate ಮಾಡ್ತದೆ. Minus indicate ಏನು ಮಾಡ್ತದೆ? Electric field and electric potential are electric field is in the direction where electric potential decreases. Correct? Decrease ಆಗ್ತದೆ. So in the magnitude consider ಮಾಡಿದ್ರೆ ಇದು ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. ಫಸ್ಟ್ ರೂಲ್. ಈ ಡೆಲ್ಟಾ ವಿ ಬೇಡ ಅಂದ್ರೆ I may simply write it as V. That delta V we considered because those two potentials are equipotential surfaces. ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ. ಅವೆರಡು ಪೊಟೆನ್ಷಿಯಲ್ ಏನಾಗಿದ್ದು equipotential surface ಆಗಿದ್ದು ಅವುಗಳ ಮಧ್ಯೆ ಡಿಫರೆನ್ಸ್ ತುಂಬಾ ಚಿಕ್ಕದಿತ್ತು. The distance between those two surfaces was very small. Hence we represented change, very small change as a delta V. Here no need to write delta. I can simply write V. This is delta L. Okay. Delta L is modular. I simply write L, or let me consider magnitude only. Also we know E is equal to V by L. ಇದು ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಲ್ಲಿಂದ ತೆಗೆದುಕೊಂಡು ಬಂದು ಈ ತರ ಮಾಡಿರೋದು. ನಾನು ಆ ಡೆರಿವೇಶನ್ ಮಾಡುವಾಗಲೂ ಸಹ ಪುನಃ ಹೇಳಿದ್ದೆ, ಇದನ್ನು ನಾವು ಭವಿಷ್ಯದಲ್ಲಿ ಈ ರೀತಿ ಬಳಸ್ತೇವೆ. ಚಾಪ್ಟರ್ ನಂಬರ್ 2 ಅಲ್ಲಿ, ಚಾಪ್ಟರ್ ನಂಬರ್ 3 ಅಲ್ಲಿ ಈ ತರ ಬಳಸ್ತೇವೆ, ಹೊರತಾಗಿ ಮೈನಸ್ ಡೆಲ್ಟಾ ವಿ ಡಿವೈಡ್ ಬೈ ಡೆಲ್ಟಾ ಎಲ್ ತರ ಯೂಸ್ ಮಾಡೋದಿಲ್ಲ. ಅಲ್ಲಿರೋ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅನ್ನ ಈ ತರ ಮಾಡಿಫೈ ಮಾಡ್ಕೊಳ್ತೇವೆ ಅಂತ ಹಿಯರ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್. This is equation 3. Now compare this equation to LHS same. LHS and LHS same. By comparing equation 2 and 3, they can write epsilon divided by sigma divided by epsilon naught is equal to V by L. Or V is equal to sigma into L divided by epsilon. This is equation 4. This expression we get, correct? What we do, we put this expression here in expression 1. Put V, this V, electric potential, in equation 1. In equation 1, what we get? I will write C is equal to Q divided by, in place of V, let me write sigma into L divided by epsilon naught. What next? C is equal to half. We know, easy ಆಗ್ತದೆ. ಮತ್ತೊಂದು ಮೆಥಡ್ ಇದೆ. This method is better. We know sigma is equal to Q by A. In the beginning only we discussed. This is also from chapter number 1. Chapter number 1 ನಲ್ಲೇ ಬಂದಿರೋ ಕಾನ್ಸೆಪ್ಟ್ ಇದು. ಏನದು? Sigma is equal to Q by A ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್. ಕರೆಕ್ಟಾ? Right? Or from this equation, Q is equal to sigma A ಅಂತ ಆಗುತ್ತೆ. Q is equal to cross multiply ಮಾಡಿ sigma A ಅಂತ ಆಗುತ್ತೆ. ಈ Q ವ್ಯಾಲ್ಯೂ ಇಲ್ಲಿ ಹಾಕಿ ಏನು ಸಿಗ್ತದೆ? Therefore, C is equal to sigma A divided by sigma into L divided by epsilon N. Epsilon not equal to sigma sigma cancel ಆಯ್ತು. Okay. So C is equal to ಇದು ಮೇಲೆ ಹೋಗುತ್ತೆ automatically. Epsilon naught I will write first A into epsilon naught divided by L. Okay. ಇಲ್ಲಿ ಒಂದು ಇಲ್ಲಿ D ಬರೋದು L ತಗೊಂಡೆ ಅಂತ ಡೌಟ್ ನನಗೆ. I think this as L only. ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ D ಬರ್ತಿದ್ದು ಇನಿಷಿಯಲಿ ಅದು ಡಿರೈವೇಶನ್ ಮಾಡುವಾಗ ಎಲ್ಲೋ L ತಗೊಂಡೆ ಅನ್ಸುತ್ತೆ. ಆಟೋಮೆಟಿಕಲಿ L ಅಂದ್ರೆ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ L ಅಥವಾ D ಅಂದ್ರೆ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೋಸ್ ಟು ಪ್ಲೇಟ್ಸ್ ಅಷ್ಟೇ ಅರ್ಥ. either D or L whatever it may. ಅದು ಹೀಗೂ ಬರ್ಬೋದು. C is equal to A into epsilon naught divided by D ನೂ ಬರ್ಬೋದು, ಎಲ್ಲೂ ಬರ್ಬೋದು, ನೋ ಪ್ರಾಬ್ಲಮ್. Okay, at the end ಅವೆಲ್ಲ symbolic representation only. Okay, this is expression for capacitance of parallel plate capacitor without dielectric medium between them or air as a dielectric medium between them. How ಕೇಳಬಹುದು as air as a dielectric medium between them, or generally we say without any dielectric medium between them. Dielectric medium ಅಂದ್ರೆ like mica, paper, ceramics, ಆ ಥರದ್ದೇನು ಇರಬಾರ್ದು. This is very 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 important, and most of the time you get what problems on this formula. ಈ ಫಾರ್ಮುಲಾ ಏನು ಬರ್ತದೆ, ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರ್ತವೆ. So prepare it very well. There are number of other methods in our textbook. Both the plates are given. ಹೀಗೆ horizontal ಕೊಟ್ಟಿದ್ದಾರೆ, ನಾನು ವರ್ಟಿಕಲ್ ಹಾಕಿದ್ದೀನಲ್ವಾ, horizontal ಕೊಟ್ಟಿದ್ದಾರೆ. They have given some short steps. Okay, ಅದು ನಿಮ್ಗೆ ಅನುಕೂಲ ಆಗ್ತಿದ್ರೆ just follow that, no problem. This is one of easier method what I do. Okay, thank you.